Hello everyone, welcome to my channel Sarin Maitri, yours educational mentor. So let us see one numerical regarding thermal properties of matter. So now here the numerical which is given to us is at the top of the mountain a thermometer read 7 degrees Celsius and barometer reads 70 centimeter of Hg. At the bottom of the mountain the barometer reads 76 centimeter of Hg and the thermometer reads 27 degrees Celsius. The density of the air at the top of a mountain to the density at the bottom is. So now here in this particular numerical there are two cases, like it is one case is on top of the mountain, another case is on the bottom of the mountain. Now here if we are having the two instruments, now one instrument is an instrument which measures the temperature and another instrument is an instrument which measures the pressure. So thermometer will measure the temperature and barometer will measure the pressure, and the values of the temperature and pressures are being given with respect to top of the mountain and bottom of the mountain, and we are supposed to find it out the density of the air at the top of mountain to the density of the air to the bottom of the mountain. So you are supposed to find out the density ratios with respect to top of mountain and bottom of the mountain. So let us write down what is given to us. Temperature, solution for this one, temperature I am taking it as top as T is equal to 7 degrees Celsius, that is equal to 7 degrees Celsius plus 273, it becomes 280 Kelvin, and pressure at the top is given as 70 centimeter of Hg, and again at the bottom of the mountain I am taking it as B as a bottom, that is equal to 76 centimeter of Hg, and temperature at the bottom is been given as Tb is equal to 27 degrees Celsius. So 27 degrees Celsius is equal to 300 Kelvin, that is 27 plus 273 equal to 300 Kelvin. So now we are supposed to find out the what is the density of the air with respect to top and bottom of the mountain. So as per the ideal gas equation, we know that PV over T equal to constant. The formula for the ideal gas equation, we know that PV is equal to nRT, but here N, the number of moles, and R, that is the universal gas constant, is not going to change with respect to top of mountain and bottom of the mountain. So that's why the variables will be only PV by T is equal to constant. If this is the case, see here now, in our particular numerical, volume is not given to us, volume is not given anywhere. So, but we are supposed to find out the density. Then how to find out density? We know the formula for density. Density equal to mass by volume. This implies volume equal to mass over density. Substitute this value in this equation. So it becomes P into mass by D into T equal to constant. Even here the mass is going to be same or constant on the top of mountain and bottom of the mountain. Therefore our equation for this problem becomes as P over dt equal to constant. What is P? P is the pressure and D is the density and T is the temperature. If this is the case, I can write my equation as P1 over D1 T1 is equal to P1 P2 over D2 T2. So this becomes your equation, and you are supposed to find out the solution in terms of density. So I will be writing my equation as this implies D2 over D1. D2 over D1 will be equal to P2 T1 by P2 T1 by P1 T2. Now I don't have P1 T2 or T1 T2, but we have with respect to top and bottom. So my equation becomes as 2 is a bottom. We can write it as 2 is a bottom initially. So now we are supposed to find with respect to what is this one, air from mountain to this one. So top to the bottom. So I can write it as in terms of top to bottom. that is equal to, now it becomes reverse of this case. So PT T bottom by that is T bottom by T top. So this becomes your numerical. So now you substitute these values. If you substitute the values, PT, what is PT? PT is the pressure at top. Pressure at top is equal to 70. 70 into what is the temperature at the bottom? Temperature at bottom is 300 over. Then pressure at bottom. Pressure at bottom is equal to 76 into what is the temperature at top? Temperature at top is equal to 280. If I cancel this one, we'll get the answer for this particular numerical. dt over dp is equal to 2 and 0 will get cancelled. If I solve this one, ultimately your answer will be 0.986. So this is equal to 0.99. So your final answer, T top to T bottom is equal to 0.99. So this is your solution for this numerical. The solution for this numerical will be 0.99. So this is your solution. Hope you have understood, students, how to solve this particular numerical, and this is the way we are supposed to find it out the volume and then put that volume in an ideal gas equation. Once if you put the volume in ideal gas equation, try to find out densities with respect to top and bottom, and you are going to get the answer for this particular solution. Thank you everyone for watching my videos. Like, subscribe and share my videos, and try to tune into my channel for further interesting topics on physics. Thank you everyone.